Hi, I'm Chem's best friend. If you need any chemistry help, the information is on the bottom of the screen. So hello, welcome back. Let's continue learning more about energy, especially enthalpy, and stoichiometry, chemical reactions. How do we do these calculations? You probably have a few homework problems to do. Let's learn how to do them. Let's go to my screen and let's talk about here. So here we have just a sample reaction. Let's say we have A plus B goes to C, and the enthalpy of this reaction is 50 kilojoules per mole, or as written. And what does that mean? Well, if it means 1 mole of A, 50 kilojoules is released. I mean, it's like, no, it's absorbed because it's positive. I always think of as exothermic reactions, but this is positive, so this is absorbed. So 50 kilojoules per mole is absorbed. That's an endothermic reaction. Well, what happens if we double everything? If we double everything, the enthalpy also doubles. Keep that in mind. Why? Because enthalpy, heat, is an extensive property. It depends on the amount of substance. Here is an easy way to remember this. If you decide to do a fire and you are really cold and wet and it's cold and you are outside and you are hiking and you really want to warm up, you can make a fire with a little branch, or you can make a fire with a whole tree that it's chopped down right there. So the fire from the branch will be very small, very little heat will be given off. It probably will not be enough to warm you up. But if you do a fire with a whole tree, you have way more fuel, way more wood. You will have a bigger fire, more heat will be given off. Yes? Is this making sense? So heat, enthalpy, is an extensive property. Depends how much. So if I double my reaction, double my wood, right, I would double the heat. So here, twice as heat will have to be absorbed. Now, if I flip my reaction from the original, now the original reaction is going backwards. Well, if original reaction had to absorb 50 kilojoules per mole, if I now go backwards, now this reaction, opposite, will now release 50 kilojoules per mole. Is this making sense? Going forwards, backwards, you flip the sign. Okay, let's do some problems. Here is a problem for us. Here is propane burning, combustion reaction. Yes, propane, gas tank burning. It has to react with oxygen, making carbon dioxide and water vapor. Here, enthalpy of this reaction is negative 2044 kilojoules. What does that mean? Well, negative right away, it means it releases heat, right? Or if you burn propane, you will feel warmth. It releases heat. So that means if you burn 1 mole of propane, it will release 2044 kilojoules. Here is the release part, right? Or if I burn 5 moles of oxygen, it will release this much, because this reaction is 1 mole per 5 moles. So how much heat is released if when 2 moles of propane get burned? Okay, let's think about this. Let's write down what we have. So if we have 2 moles of propane, right, of C3H8 times, well, there is negative 2044 kilojoules, yes, is released when 1 mole of propane burn, C3H8. So that means if I double my propane, if I double the amount, I will have double the energy released. Yes, is this making sense? Let's go a little bit harder, right? Okay, so I'm going to keep the same reaction, but how much heat is released when I have now 16.5 kilograms? It's a lot of propane. How much heat will be released? Let's go through here. So write down first the number given to you, which is 16.5 kilograms of propane, C3H8. I probably have to change it to grams. Yes, let's change it to grams. Usually this will help us. And then we will change it to moles. Do you see it? Kilograms, change it to grams, change it to moles. So I'm going to say where there is 1,000 grams, yes, in 1 kilogram. And I wrote this number here because I need to change my now grams of propane to moles. And here is my molar mass of propane, right? Carbon 12, 12 times 3 plus 8. Yes, 36 plus 8 will be 44. So I quickly did this ahead of time. And so I'm going to have 1 mole of propane, C3H8, is 44 grams of propane, C3H8. And what? There is what? Negative 2044 kilojoules of heat is released when 1 mole of propane burns, C3H8. So if we're going to plug this number in a calculator, we get negative 766,500 kilojoules. That's a lot of energy. And we need 3 sig figs. Yes, 3 sig figs. And this will be negative 767,000 kilojoules. That's a lot of propane. So that's a lot of energy. Okay? We got this. So if you have grams given, change it to moles, and then use that information given. One more problem. Let's make it a little bit harder. So what's going on if I have how much heat is released? And I'm asking it's released because I see that negative sign. So how much heat is released when 80 grams of water vapor is made? So 80 grams of water vapor, how do I deal with that? Okay. The same as I did before. So if I have 80 grams of water, let's change it to moles, yes? So 1 mole of water, well, 1 mole of water is how much? 18 grams per mole, yes, 18 grams of H2O. And there is negative 2,044 kilojoules released per, well, this is how much heat is released per, right there, what do I see? Per how much water? Per 4 moles of water, right? Per 4 moles of water produced. And I plug and chug, and my units nicely cancel out, and I'm going to have negative 2,271 kilojoules, but when I look at my sig figs, I need 3, so negative 2,270 kilojoules. So this problem, again, it tells us it's released, how much heat is released, and I wanted you to notice this. This is how much heat is per 4 moles of water. That was I wanted to watch you because I wanted to really emphasize, because here it was per 1 mole, and over here was also per 1 mole. It was, you know, the equation originally, this was 1. So I wanted to include something a little different. All right, so hopefully you can see that enthalpy calculations and stoichiometry with chemical reactions are actually pretty easy. And see you next time. Thanks for watching.